So this is going to be a lesson on radicals, and basically we're going to start out by talking about square roots. Basically, square roots usually don't have a number right here, but there's an invisible 2. Okay, this little symbol is called the radical. The number inside the radical is called the radicand. And basically, when you're solving a square root, you're looking for what number that multiplied by itself give you that number inside. So in this case, what number that multiplied by itself give you that 4 that is inside? And the answer is 2. Okay, what we're going to do today is we're going to look a little bit behind the scenes of how to simplify radicals. Okay, many of us know that square root of 4 is 2, but we're going to take a closer look on what's happening behind the scenes. Okay, basically what we're going to do is do the prime factorization of 4. What two numbers give me 4? The answer is 2 times 2. 2 times 2 will give you 4, and because 2 is prime, you put a circle around it. Alright, so that means 4 can be rewritten. Instead of writing 4, we can write 2 to the second power. Okay, there's two 2's here, so it'll be 2 to the second power. Now, to be able to remove this 2 out of the radical, you have to be able to divide the exponent by the invisible 2. Can I divide 2 by the invisible 2? Yes, I can. So that means this base 2 can come out. And when it comes out, you divide the exponent. So 2 divided by 2 is 1. And that means your answer is a 2. So that's what's happening behind the scenes when you're doing square root of 4. So let's take a look at square root of 81. Okay, what two numbers give me 81? Well, that would be 9 times 9. Is 9 prime? No, so let's break it down. This would be 3 times 3. And so is 3 times 3 here. So how many 3's do we have? We have 4 3's, so that means this would be 3 to the 4th. And we ask ourselves the question, can the 3 come out? And the answer is yes, because you can divide the 4 by the invisible 2. So that means this will become 3 to the second, which is 9. Alright, let's do one more. 144. What two numbers give me 144? That would be 12 times 12. Are they prime? No, so let's break it down. 3 times 4. 3 is prime. 4 is not, so let's break it down as 2 times 2. Very well. And we'll do the same for the other 12 here, so there'll be 3 and 4. And 2 and 2. Alright. Very well. So how many 2's do we have? If we count, I have 1, 2, 3, 4. So 2 to the 4th. And then 3 to the second. And can the 2 come out? Yes, it can, because you can divide the 4 by the invisible 2. And can the 3 come out? Yes, it can, because you can divide the 2 by the invisible 2 also. So the 2 comes out as 2 to the second, and the 3 comes out as 3 to the first. So 2 to the second is 4, times 3 is 12. Okay? Alright. Now, what if we have square root of 8, for example? Okay? Let me move up the paper here. Let's do the same process. Do the prime factorization. This would be 2 times 4. 2 is prime. 4 is not. So let's break it down. This would be 2 times 2. So in other words, square root of 8 is 2 to the third power. Now in this case, can I divide 3 by the invisible 2? And the answer is no, because I get a decimal. So what can I do here? Well, let's think about it. 2 to the third power is the same thing as 2 times 2 times 2. Okay? And because of that, instead of writing 2 to the third, I can rewrite this as 2 to the second, 2 to the first. Right? 2 to the third is the same as 2 to the second times 2 to the first. 2 plus 1 is 3. I have 3 2's there. The advantage of writing this way is because before I cannot remove a 2 but in this case I can remove this first factor here. I cannot remove this guy, but at least I can remove this one. So this one is going to come out of the radical as 2 to the first, and the other one stays inside the radical. So my final answer, my simplest radical form, is 2 square root of 2. Okay, and that's the power of doing this prime factorization, because it helps us simplify radicals. Alright, let's go to the next problem. So let's say I do letter E right here. Okay, and what we're going to do is first do the prime factorization. So the prime factorization here would be 2 goes into 96, 2 goes into 9 4 times, there's a remainder 1, so 2 goes into 16 8 times, so 2 times 48 gives you 96. Now let's split this guy. This would be 4 times 12. Are they prime? No, they're not, so let's split again. This would be 2 times 2, and this would be 2 times 6, and this would be 2 times 3. Alright, so this is my prime factorization. So as I can see, this would be, how many 2's do I have here? 2 to the 5th, and I have 1 3, and I have x to the 7th. Alright, with that, can I remove anything from the radical? As it's written right now, I cannot remove it. So what I'm going to do is I'm going to rewrite my radical, and I'm going to rewrite my terms over here as 2 to the 4th, 2 to the 1st, because 4 plus 1 is 5. There's nothing I can do with the 3, so just copy it down. And for the x, this would be x to the 6th times x to the 1st. Alright, now who can come out of the radical? Anything that can be divided by 2 can come out. So 4 can be divided by 2, so that means these 2 come out. This guy cannot come out. The 3 cannot come out. The 6 can come out because not the 6, but the x can come out. And the last x that cannot come out. So 2 to the 4th comes out as 2 to the 2nd. This guy stay, this guy stay. This guy comes out as x to the 3rd. And what's left inside the radical? The 2, the 3, and the x. And 2 to the 2nd power is 4, x cubed, and inside the radical I have 6x. So this would be my simplest radical form for this particular problem. Okay, alright, now we're going to go on to the next problem. So let me move up here. Suppose I have this problem right here. So if you notice, this one I have a number outside, so that's okay. Basically, let's gonna start with the numbers inside. So what two numbers give me 625 and let's see, not 625, 675. The numbers would be 5 and 135. 5 is prime, put a circle on it. Then I would break 135 as 5 and 27. What two numbers give me 27 would be 3 and 9. 3 is prime, 9 is not, so break it down 9. This would be 3 and 3. Alright, very well. How many, one thing I need to remember is that because I have that number outside, make sure you copy it. And inside the radical, I'm going to have 3 to the 3rd, 5 to the 2nd, x to the 5th, and then y to the 4th. Now, let's see, can we rewrite some things here? Yes, we can. We definitely need to rewrite the 3 to the 3rd as 3 to the 2nd times 3 to the 1st. The 5 to the 2nd is okay. The x to the 5th needs to be rewritten as x to the 4th, x to the 1st, and the y to the 4th is fine as it is. Okay, now we're going to put arrows on what we can remove. We can remove the 3, we can remove this 5. We can remove this x and the y. So when we remove that, I'm going to get 4x squared. The 3 comes out as 3 to the first. The 5 is 5 to the first. X to the second. Y to the second. And inside the radical, I have left 3 and an x. Okay? Alright. So now, with that, we get, I'm going to combine these numbers here. So 4 times 3 times 5 is 60. I'm going to have x to the fourth. I'm going to have y to the second. And inside the radical is going to be 3x. Okay? Alright, very well. Let's go on to the next problem. The next problem, if you notice, there's going to be a 3 now. So now we're moving away from square roots and going to cube roots. But the same strategy applies. First, do the prime factorization. This would be 3 times 9. How do you break down 9? 3 times 3. So this would be the cube root of 3 to the third x to the ninth. And basically now, instead of dividing by 2, we're dividing by 3. So can these 3 come out? You bet, because you can divide the exponent by 3. And so does the x can come out because you can divide 9 by 3. So when you divide them, or when you take them out, the 3 becomes 3 to the first, and the x is x to the third. So my final answer is 3x to the third. Alright, let's try the next problem. The fourth root of 81. Again, prime factorization. Always do your prime factorization. 9 times 9. And then this would be 3 times 3. Put circles around it. How many 3's do we have? We have, in this case, 4 3's, so 3 to the fourth. Can the 3 come out? You bet. This would be 3 to the first, or in other words, 3. Okay. Alright, let's try one more. Suppose I have now the fifth root of 64 x to the 11th y to the 27th. Again, same thing. I'm going to have 8 times 8. This would be 2 times 4. 2 is prime, 4 is not. So this would be 2 times 2. 8 is 2 times 4. And this would be 2 times 2. So how many 2's I have here? I have 2 to the 6, x to the 11th, y to the 27th. Alright, can I rewrite these guys? You bet. Because I want to make sure that I have exponents that are multiples of 5. Because if I have multiples of 5, I can divide by that number here. Okay, and that means that number can come. The number can come out. So I'm going to rewrite 2 to the 6 as 2 to the 5th times 2 to the 1st. On the x, I'm going to be x to the 10th and x to the 1st. And then it will be y to the 26th and y to the 1st. I'm sorry. Y to the 25th and y to the 2nd. Alright. Now, can the 2 come out? You bet. Because you can divide 5 by the 5 over here. The x to the 10th can come out because you can divide 10 by 5. And so can the y to the 25th. So when they come out, the 2 is going to be 2 to the 1st. X will be x to the 2nd. And the y will be y to the 5th. And inside the radical, I'm going to have 2x and y squared. So in other words, my answer is, just erase that 1 right there. My final answer is 2x squared y fifth times the fifth root of 2x y squared. Alright, why don't you stop the video right now and try these problems right now. Okay? Once you finish these problems, turn on the video and check the answers that I'm going to show in a few seconds. Okay. Alright, welcome back. These are going to be the answers for the practice examples. So let me show you the answers right now. These were the first one, and this one was the second one. Okay, remember you can stop the video and take a closer look at these problems. Okay, let me show you the next one, letter C. Letter C is right there. And let me show you letter D. Okay, I just need to fix here. This is supposed to be letter D. This is going to be letter E on the bottom here. I'm sorry. So here's letter D. Here's letter E. And the last one is letter F. Remember, you can stop the video and take a closer look at the problems. And here's the last one. Alright. Okay. Well, this concludes the lesson on radicals. Thank you very much for your time and have a great day.